First of all, I'd like to say thanks to everybody, and hope you had a good Labor Day weekend. And I guess you all got so bored doing nothing but laying around on the sand or swimming pool, whatever you were doing, that now you decided you get really bored and listen to me talk about ropes. So I appreciate all of your time and everybody showing up, and hopefully you'll find this of some use. So without further ado, let me get into it. Popular types of rope construction. Here is, we're going to talk about why you would choose one rope over another for different applications, and that's what this talk is all about. There are some pretty common or popular types of rope construction that are out there. I think everybody is familiar with the three-strand laid ropes that have been around since ever. They were probably the original ropes, and I think you can go to the pyramids in Egypt and probably find pieces of grass ropes that were twisted up thousands of years BC, and it's probably one of the oldest tools, and the three-strand is pretty much the original design. We'll get into all those here in a second as we move along, and I'll explain them. The first thing, as I said, is going to be construction, and here we go. Here we go. Come on, computer. Three-strand laid is just that. It's basically twisted yarns where you start with grass or hemp or nylon or whatever you're going to make it out of and twist it. The smallest, if you see the upper illustration, the smallest bundles are twisted into bigger bundles, which are then twisted into even larger bundles. Those bundles are basically all the load bearing. So the inside and the outside are both load bearing, and so if you rub the outside of the rope, you're also wearing the load bearing strands of the inside of the rope. The other thing with this rope is it twists. It gives you a lot of spin once you rappel it in free air. The cavers tried using three-strand ropes in these vertical pits around here in the southeast, which is one of the big reasons why we came up with trying to find another rope to rappel into, because you would rappel a 300-foot rope in free air and to the bottom of a pit where you don't touch the wall, and you get off the rope and pass out or throw up, or depending on how well how you handled motion sickness. The next rope we're going to talk about is 8-strand plated. I don't see this very much anymore in the rescue rope, but it's a real popular rope for other purposes. The common one is there's a lot of marine ropes that are made out of plated ropes, and it's kind of like hair braiding was. If you made lanyards at summer camp when you were a kid, this is a really basic thing. It's a very loose construction. You can actually push a carabiner through a 3/4 inch 8-strand plated rope just by shoving it through. So it picks really bad, and it doesn't really wear very nice, but it's a very soft rope, and it runs well through rigging because it is soft and pliable, but it also wears very fast. So then we get into the braided constructions, and this is what most of us have now moved towards in the rescue community for sure. And there's a bunch of different kinds of braids. Popular ones are solid braid, which is probably one of the original ones. It's typically used for things like ski tow rope if you're a water skier. You'll also see hollow braids, which is like the outside of a Cormantle rope, where it's hollow in the inside. Some of them are hollow with absolutely nothing, air in the middle. Others have fillers where you'll see chopped up cellophane or whatever stuck on the middle of it just to fill it up. Then there's braid on braid, which is also known as double braid, and that's where you have a a solid braid rope with a hollow braid sheath on the outside of it. And then lastly is kernmantel. And kernmantel is the German word for a core and sheath structure of making rope construction, where you have an inner core wrapped over an outer sheath. The kernmantel is by far the more popular one in the construction that we use in the rescue market. And we're going to talk a little bit about the typical ones that and types that we use and the standards that affect that. The static kernmantel definition goes back to a long time. People have been using that term for years and years and years, and it became pretty confusing because in Europe people were calling ropes static ropes, and in the States people were calling ropes static ropes to imply any low stretch rope. And so now, I guess 10 or 15 years ago now, the Cordes Institute wrote a standard to try to write definitions to explain the difference in what we mean between the Europeans' version of a static rope and the American version of a static rope. And we basically took 6% at elongation as the breaking spot between what we would call a static rope and what they call a static rope. And we call these ones that are in the 6 to 10% range now low stretch rope, and that would be the typical European more stretchy kernmantel ropes would fall into that low stretch nomenclature of the 6 to 10% elongation at 10% of the rated breaking strength. And the pure static ropes are less than 6% elongation at that same 10% of breaking strength. So all of that came about to try to provide a little less confusion between the CE standards and the US NFPA and other people that were calling things static ropes. And for the most part, I think that's kind of gone away, and that most people now are getting pretty good on those two terminologies after, I guess, 10 years of using them. Though there's still people that think that we shouldn't call them static ropes because no ropes are purely static, but there's just a few of those people left out there that want to argue the physics definition of static, I guess. But anyway, and then the last one, of course, is dynamic rope. And dynamic ropes, they're all based on the UIA climbing standard, which has been around for well over, I guess, 50 years now. And they're talking about very high elongation, lower impact loads used for mountain climbing. And those are typically 8% at body weight, 8% elongation at body weight. So you can see there's a big difference between 6 to 10% at 10% at breaking strength and 8% at body weight. And they go all the way up to 40 or 50% at break, where a static, typical static rope like a PMI rope would be more like, depending on which one, somewhere like 17 or 22% elongation at break. So that's enough about that. The static kernmantel design, what it really looks like, this will give you an idea of the difference between the two ropes. You'll notice that the white core sticking out to the right of your screen of the drawn rope has a few twists in it. The core has to be very low twist to eliminate mechanical elongation. Most of the elongation in the typical static kernmantel design comes mostly from the yarn itself and not from the mechanical property of the yarn. It only has enough twist in it really to hold the yarns together and control the yarn while we manufacture it. The low stretch is Very similar construction as you can see, but there's a difference in the amount of twist in the core yarn. The core yarn has much higher twist, so you get more mechanical elongation of the yarn itself. And therefore, there's mechanical elongation along with the elongation of the yarn. Let's see if I can back up. You can, yeah, there, I'll back that. So you can see the difference between the twist there and the twist here. I'm getting a little bit of feedback. I don't know if other people are picking that up or not, but I'm getting a little bit of echo feedback. Hopefully the rest of you aren't getting that. Dynamic kern mantle is higher twist again, and in addition to being like the low stretch where it is high twist, but it is typically heat treated, and they heat treat the yarn to alter the elongation properties of the yarn. Another trick is to use a different type of nylon than what's typically used in the static ropes. They use a nylon type 6, which has more elongation than nylon 6/6, which is what PMI uses in our classic static ropes. And we'll talk about that a little bit more in a minute. But the mechanical elongation of the twist plus the heat treating plus a different yarn all gives the dynamic rope its extra elongation. And because it's done with heat treating is why as you take more and more falls and use it more and more, dynamic rope tends to have a little bit higher impact each time you take a big fall on it, because you're slowly pulling out that elongation that you just kind of steamed into the rope. To talk about diameters of these ropes and their numbers of carriers, I guess the 3 illustrations here are all the same diameter rope, but you can see that they have different numbers of carriers on the braid. It's also known as picks. The yarn crossing each other are picks. The carriers are the machines on the machine that on the braider that carries the rope around and around. And if you've never had a chance to tour a factory and see one of these ropes being made, envision a maypole type operation where you have yarns going clockwise, half the yarn's going clockwise, half the yarn's going counterclockwise, and they're passing over each other time after time after time as they run down the rope as the rope's being made. And a 48 carrier braid sounds like you're getting more, so it ought to be better, but not necessarily. What you get is a more flexible rope, because the sheath yarns, to cover the same distance and have 48 of them and not to run on top of each other and actually overlap, would have to be smaller than a smaller number. You see, if the 16 carriers, the actual sheath yarns are big and thick so that they can touch going all the way around. So you sacrifice a little bit of core, but you gain sheath thickness, and that's a selection issue. Is do you want something that's suppler and thinner sheath and easier to handle and tie knots in, or do you want more yarn to wear away before you get through to the part that is carrying the load and protection of the sheath to give you a better, stronger rope? So it's one of the many decisions you have to make as a rope purchaser is, how many carriers do I want versus for protection of the core versus how much flexibility and how smooth a rope do I want to have. And this is one of the key things that changes that right there. Another thing that's different from these constructions is the relative elongation. Just if everything else is pretty much the same, this gives you an idea that the plated rope would actually make pretty good dynamic rope, except it would catch and drag on everything because it has a lot of inherent elongation because it's just so loose. Laid rope are stretchy for all that twist that's in it. Static rope has the least amount of normal elongation, and then dynamic is back up there a little bit greater than the typical laid rope. Of interest is this year, or for 2012, there has been suggested, and it will be discussed and voted on over the next year, to add laid rope as a possibility for the NFPA 1983. It was prevented because of the elongation curves allowed for the typical rescue rope, but now they're going to make a special higher elongation or medium elongation that'll fit in there between. It'll be more than low stretch and less than dynamic, and that's hasn't happened yet, may not happen, still has to be voted on, but it's being considered for the next issue, which would be the 2012 edition of NFPA 1983. Relative rope strengths, another shopping thing for some people. Strength is a really big issue. Obviously, it needs to be strong enough to do the job that you need. I can't answer that question for you as to how strong what needs to be. Only you know that, but I would say that if you're worrying about breaking a rope in a regular operation that it's over 5,000 or 6,000 pounds, that you're probably doing something wrong, because it really shouldn't be a big issue on the strength. But just knowing this chart gives you an idea that there is a relative difference between your dynamic laid and plated ropes and a static rope in strength, just all thing else being the same. There is some strength gained by having the construction, the static construction. Let's talk about what the minimum requirements are. Here's NFPA 1983. A lot of you users are probably pretty familiar with these numbers. General use is 40 kilonewtons or greater. Light use is 20 kilonewtons or greater, and escape is 13.5 kilonewtons. So it gives you that 9,000 pounds on the general use rope, which for most people is a 1/2 inch rope. The standard actually allows it to be a little less than that, but I don't know that anybody's been able to build one that meets the 9,000 pounds yet and the elongation curves. It'll be interesting to see when and if that happens. Here's the CI 1801, the Cordage Institute, their standard 1801. These are minimum strengths for a lot of other definitions of life safety rope diameters. You guys can read these. Each rope has a minimum breaking strength, which is pretty much the same kind of numbers the NFPA has got. They just go down to 7 and 8 mil, and they have one for 16 millimeter too. So it's a different standard, but it is another life safety rope standard that published by the Cordage Institute here in the United States. And if anybody would like more information on these standards, drop me a note afterwards, and I'll be glad to provide you with the background on some of this stuff and where you can get copies of it. UIAA, the Union International Alpine Association, the mountain climbing folks, have an international standard. It's a truly international standard for static ropes. I don't believe they actually have a slow pull static strength requirement. They do have these 5 drops, 80 kg mass, which has to have less than 12 kilonewtons. So that's not a big issue for most of us, but it's something that may be of interest to some of you. Now these are not, I said static ropes. These are the dynamic ropes. UIA 101 is the dynamic ropes. Diameter requirements. Once again, NFPA 1983 has the general use range is 11 to 16. That was a change in the last edition, where it went from 12.5 being the minimum to down to 11, as I said before. What that gives you is the ability someday that somebody can make if they can make a 9,000 pound rope, they can use 11 mil. That hopefully someday will happen as yarns get better, and the ability to do that happens. Light use 9.5 to 12.5, and escape 7.5 to 9.5. A lot of people have asked why Escape has a minimum at 7.5, and the committee felt that it was about the minimum diameter you could feel through a fire glove, so that you could still even tell that you had a rope in your hand. And I'd say that's unusual for most fire gloves to even be able to feel that through it, but you sure can't feel it if it's any thinner than that. So that's where that range came from, was what you can still feel in your hand while you're trying to operate the device. And I've said about that, I guess. Now let's talk a little bit about materials, which probably has a lot to do with your choice when you're buying a rope. There, when we first started in this business, it was pretty much everything was either natural fiber or nylon, and since then there are a gosh awful numbers of other yarns out there. There are two major types of materials and two major kinds of rope plants: the plants in the ground and the plants that you build out of concrete and steel. And the natural fibers pretty much got legislated out of existence by things like the NFPA standard, that they have some problems, and we'll talk about the differences between natural and man-made fibers. But they're still made and they're still out there. So your natural fibers, manila, sisal, cotton, there's a lot more of them, hemp. They're certainly easy to make. People make these ropes by hands all over the country, all over the world still today, to make big monster ropes that are still used to do things like suspension bridges in faraway third country lands, and they work okay. The thing is, you have to remember is that the stuff degrades and you have to replace it pretty easy. It actually gets stronger when it's wet until it rots. And once it rots, it's hard to tell it's rotted, but you lose all your strength. Really useful thing is it's digestible by livestock. If you're going to leave your rescue ropes out in the middle of a pasture, it's a big issue. It's a point here because it's still used here in the States as baler twine because it is digestible versus the plastic ones, which aren't really good for the insides of animals. Big problem with them is that they aren't continuous fibers, and depending on the quality of the plant, you can have a very, very long fiber or a very short fiber, long being a foot or two versus short being a few inches. And obviously the more the fibers are intertwined, the more strength you get out of it. So when somebody says they have a first quality manila rope that was great, well, it was probably back before the manila plant blight, and long strands of manila were still available commonly, and manila rope has changed through the years because the plant isn't as hardy as it used to be. Has a low strength per weight and really poor chemical resistance. So those are the big reasons why we never did get very much natural fibers in the fire service, and after nylon came around, it was an easy change, I think, to go into man-mades. And this nylon was the first most popular one out there, and here's the numbers on it. The 7.8 to 10.4 grams per denier. That's a G/D. It's a unit of the fineness of silk, and some artificial fibers such as nylon is equal to 1 gram per 9,000 meters of yarn. So it's been superseded now by other units, but we tend to still talk a lot about grams per denier, and some of these old numbers are still in my slides, but it gives you an idea of a way to measure the strength of one yarn to the other. So it's a good number to compare from one product to the other. Most of the typical yarns that we buy in the nylons are right up there at the 10 range, or now the yarn has, in the 35 years we've been in business, the nylon has just gotten progressively stronger, slowly, at very, very minute amounts every few years. The specs kind of seem to creep up on the grams per denier on some of these yarns, and it's gone a long way from the beginnings of PMI to today. Specific gravity is certainly important to some of you. If you're using ropes for water rescue or stuff, having a specific gravity greater 1 is obviously not a real plus. If you want the rope to float, it's not going to float long once it gets wet and gets smashed up in white water. It's going to go right to the bottom. 15 to 28% elongation at break. That's kind of like on the yarn itself and which manufacturer. There's really 2 different popular types of nylons used in the cordage world for life safety ropes. There's the type 6 and type 6,6 or 6.6 as is referred to. The 6.6 is the original DuPont nylon that was the original patent. The 6 was the guys that came along trying to come up with something close to it that was around the patent. They're very similar in their features. A little bit of difference in the melting temperature. You can see at the bottom bullet point there. A little bit difference in the melting point, a little bit difference in the elongation, and a little bit difference in the strength. The 6.6 tends to be stronger and have less elongation and a higher temperature point. The 6 has more elongation, a little lower melting point, and not quite the same strength or tenacity. One's not particularly good or bad. It's just which application you're going to put the rope into, so which one makes the best capabilities. Because it has this inherent elongation, it has great shock absorbing ability, and nylon has a 250 degree Fahrenheit high temperature working limit. Beyond that temperature, it's not that it fails, it just starts losing some of its properties and strength. And the closer you get to the melting point, obviously the more permanent that is, and the uglier it gets. If you happen to be hanging on a rope at 300 degrees, you probably wouldn't be happy. Hopefully none of you will ever be doing that. More about nylon. It has good abrasion resistance. It's about 10% stronger than polyester when they're dry. It does lose 10% of that strength when it gets wet. Nylon gains it back when it dries out, but it'll be 10% less strong than the numbers that you will see in the catalogs and stuff when it's actually wet. It has, like we said, really good energy absorption even when wet. It's twice the energy absorption of a polyester rope. And its chemical resistance, it tends to alkalize a little bit better than it does acids. But if you look at that pH range, 6.5 to 10.5, that's probably not a bad range to work in for most people anyway. If you're working on stuff outside of those ranges, you're probably not going to be very happy about it for very long anyway. Polyester, another really popular fiber now that's come on the market, big in the rescue ropes in the last, I guess, 10 years or so. We've been a little slow to adapt it here at PMI over the years simply because of it takes a little bit smarter user to use it, and that's because of the lower elongation at break. I think now that most people know a lot about it and have been using with it, it's a different animal than it was when it first came on the market. So we do offer a number of polyesters ourselves. But as you can see, the strength range, the grams per denier, it's about the same as nylon. It has even a greater specific gravity, so it's going to sink to the bottom even faster. It has much less elongation at break. It's 12 to 15%, where the nylon was half again that, I guess. It has, instead of excellent, they call it very good shock absorption ability. It means that it isn't going to break, but it really doesn't elongate very much. 275 degree high temperature working limit on polyester. It has good resistance to some chemicals. It likes acids better. Its pH range that it likes is 3.5 to 7.5. So if you guys are going to rappel into tanks full of 3.5 pH acid, pick your polyester rope to do that, and good luck. It has good abrasion resistance, melting points 480. It does maintain its same strength when wet, unlike nylon, which reduces a little bit. And it has a very low ability to absorb dynamic energy compared to nylon. It's not a great choice if you plan in the fall. Polyolefins, which are the polypropylenes and the polyethylenes. These are the cheap ropes that you see out there. Industry uses a lot of them for, and you see a lot of construction workers using these as life safety ropes, but they're big diameter, and they're big diameter because of the strength. They need to go pretty big to get the same kind of strength out of it. The cool thing about them is that they float. The 9.1 specific gravity makes your polyolefins a really great choice for water rescue, even though they're not particularly very strong. You see the 6.5 grams per denier breaking tenacity versus the close to 10s that we were seeing in the nylons and polyester. So you're working at 60% of the strength for the same amount of rope there. So it's a good choice if you want some elongation and you need something that floats and you don't need a lot of strength. The big thing that I have a problem with in most applications is this temperature limit. It's pretty low, 150 to 200 degrees. If you try to rappel with it or do something like that, you're just probably gonna melt right through it, or certainly melt the heck out of the rope in a rappelling device or something at 150 degrees. It'd be easy to ruin the rope pretty fast. It's inexpensive. Now, of the yarns we've talked about, I haven't said much about price, but nylon by far is the most expensive of the three we've talked about so far. Polyester is, as a material, is about 2/3 the cost of nylon right today, and polyolefins are much cheaper even than the polyester. So it's by far the cheap rope, which is why you see it used in so many utility type things, and you'll find it on reels at your local Lowe's or Home Depot. It has a great chemical resistance range, pH 2 to 12. So it's if you were looking for something to lower yourself into a vat of acid, then I guess you might choose your polyolefin. Just make sure that it's not hot acid when you're doing it. But I hope people aren't lowering their friends into hot acid anyway. It has low abrasion resistance and poor UV resistance. It always amazes me to see this sitting out on the roofs of buildings where people are using it as life safety ropes for their guys on swing stages, and they're using polyolefin ropes that are just sitting out in the sun all day long, day after day after day. It really does degrade pretty fast in the sunlight. It's not really a great choice for that if you're around the typical sunshiny tops of roofs. Other fibers that are out there nowadays, the Aramids are certainly coming out there, and we'll talk a little bit about that. These are your fancier yarns. 18 to 26.5 grams per denier is pretty normal. High specific gravity, so they definitely don't float. Really low stretch. The elongations are typically 1.5 to less than 4, which means you're kind of like in there with steel cable. Good high temperature rating. 350 is a working limit. 350 F is a working limit, which is pretty nice. Poor dynamic energy absorption. That's because of the low elongation, obviously. And some of them have a definite self-destruction action, where the yarn fiber itself, when braids past it, the fiber itself has little like barbs on it. If you look at it under an electron microscope, and it tends to, as you bend it back and forth, kind of abrade on itself some, which kind of is why it just tears up so fast. If you talk to police with Kevlar vests, they will tell you how often they have to replace them. And that's because the flexing and normal wear and tear of it just wears them out pretty fast. HMPE ropes, Spectra and Dyneema are examples of those. 30 to 35 grams per denier. These are These are ropes that are nice and strong. They don't float. They do float. They have a specific gravity of typically 9.7, which is really great. And so if you want a strong water rescue rope, this would be the one to use right here. The 150-degree melting point is the same kind of problem as you have with the polyethylenes. And that's because they're very similar fibers. The Aramids and these HMPEs are both basically modifications of other yarns that have been altered to line the molecules up straight, and you get a lot more strength out of them and a lot less elongation, but they still have the similar fibers of their family of ropes, and HMPE is high molecular weight polyethylene, so it's going to be a lot like the polyethylene ropes. So the other thing you have to be careful with Spectra and Diamine is a yarn. It's very slippery. We did some testing years ago, and you can do a pull test with double fisherman's on a Spectra rope, and the knot will just kind of untie itself, just slipping past each other just as it loads up. It's pretty easy. You need to do triple fisherman's and things like that to try to get pretty decent strength out of those types of yarns. So you want to be real careful. That's why you'll often see them blended with other yarn fibers to make them easier to sew and to tie knots and things like that. They're often blended into other fibers. And then the intended application is certainly important in what you're doing with ropes. You guys should, if you're in the fire service, I don't really know who all's out there listening, but if you're in the fire service, then you're going to want to pay attention to NFPA 1983 and the requirements of that. But be advised that even 1983 only talks about certain applications. It doesn't include lead climbing. So if you need a rope for fall protection in a lead climber situation, you would not choose an NFPA 1983 rope at this point, because it doesn't address that. It addresses rescue ropes and water rescue throw lines, and it talks about escape ropes, but we pretty much aim you at the UIA ropes for doing the lead climb, like you would have a jumper on a bridge or somebody on a tower or something like that, where you needed to do unprotected climbing where you couldn't put a top rope in. Then you'd want to use a rope that with high energy absorption, like dynamic climbing rope. So you need to know your application. Even if you came in a big red truck, it doesn't necessarily mean that you have to use just the NFPA ropes, or that they're the right ones all the time. So we talked about the NFPA general light use, and people are going to hate me for saying this because I'm really trying to get people out of this 15 times, but just to talk about that, in the NFPA standard, many people think that it tells you that you have to build systems that are 15:1 ratio. It doesn't say that. I don't think it's ever said that. It talks about that if you consider the design load being 600 pounds, that the minimum strength for that general use rope is 9,000, and it happens to be that that's a ratio of 15:1, and that number was thrown out there because ropes have edges that they go over, they have knots in them to be usable, they wear, they get old, lots of things happen with them, and so we were specific to give it a bigger safety factor between the design load and the rated braking strength in these ropes to make that kind of fit any build that you're typically going to use in a fireground operation. It didn't mean you were going to build a system that was 15:1, and really like to get rid of that bad idea out there that every time you build a system it has to be 15:1. I would guess that most of them are 7 to 10, and they work fine all the way down to a little bit more than 1 to 1 as long as nothing goes wrong, nothing unplanned. But yeah, something more like 7 or 10 to 1 is probably a minimum for most of us out there. So you need to know what your use is, and whether you want a general use and a light use. A lot of people a lot of teams are using light use ropes all the time with multiple people on them, and they don't have any problems. And it's because they are, I guess, enough of a technician to be able to figure out their loads and their safety factors, and they've got, even with a lighter use rope, they've got their 10 to 1 or whatever they felt was their safety ratio that they wanted to have, and they were able to rig that up using a light use rope. There's no reason not to do that, but that's a departmental decision that I can't make for you. Escape rope is a little bit less safety ratio in that, because it was not expected to be used a lot, and they wanted to make the rope really small so you could get it into small packages, and most people respected if they ever used it for real, they were going to get rid of it right away. So it's a little bit less design load, and so if you're going to do a lot of training or you use this over and over again, you might pick a different rope than you would with just doing one for your own little pocket to use it once and bail out. Once again, if it's not single use, you might want something bigger. Or if you've got some kind of descender you've decided that works better on a smaller diameter rope and you don't care whether or not you can feel it through your glove, I guess you could also choose to use something smaller diameter. That's going to be up to the user again, and those are the kind of things that people need to make in their selection process. A little bit about elongation here, to give you a chart idea of what that kind of, some things that mean. This is an old chart we've had around. The PMI, the far left to the just outside the red zone is the minimum elongation that will still be an NFPA rope. If it's in the red zone, it's below the 1% that NFPA allows. You have to have 1% is the minimum. So the green zone is that 6 to 10%. I mean, the 1 to 6% of the static rope, and the blue zone is the 6 to 10, and the yellow zone is everything that's greater than 10, which would include dynamic ropes. And so you can see that our 11 mil polyester rope, the far left one, just barely does even meet the standard because of the elongation issues. We're right on the edge of the curve, so to speak, where our classic rope that we've been making since 76 is the green rope, and they're kind of right in the middle of what's allowed by the standard. Our Access Pro, we used to call it P6, but now we call it Access Pro, and the Blue Order 2 ropes of old kind of fall into that blue low stretch zone. And I think you'll find a lot of other ropes out there in the market that fall into that zone. So most rescue ropes are either green or blue, hopefully, because that's the range that the NFPA ropes fall in. And depending on what you're doing with the rope and what you like, you might want to pick one at one end or the other, or in the middle of those things. And you should be able to get that information from the manufacturer of your choice on the ropes you're shopping for. And then the yellowish part of the slide is all the stuff beyond the low stretch definition of Cordage Institute 1801, all the way out to dynamic rope. And you can see the reddish line in the yellow is a 10.6 millimeter PMI dynamic rope. Just a side note to some of you who may not realize this, but even though there are dynamic ropes out there that are rated for X number of falls, those are all rated around an 80 kg climber, 176 pounds, I think that is. So Most fire service guys with all their gear are probably more than 176 pounds. You should not go to skinny ropes just because it passes the UIA test. You should probably be sticking with the fattest, closest thing you can get. Some people still make 11 millimeter ropes. I sure wouldn't go less than 10.6 with big guys, because you lose the impact ability, and the forces go up when you take a fall very quickly as soon as you do that. So I've got some numbers here, which you guys can look at this later when you can go back and see this seminar later and get the numbers if you want to do it. But these are typical numbers of PMI ropes, and I'm just going to blast through this so we can get to the question section. These are all nylon ropes. We also have some polyester core ropes. The Talon and the isostatic are both polyester core. The Talon has a nylon sheath on the outside, which makes it feel a lot better. Polyester is really, really slick, and so some people like having the mixture of the nylon and polyester to repel and handle a little bit nicer, like their old nylon ropes, but have the low stretch for rigging stuff where they don't want stretch, like in a highline situation or something like that. And the polyester yarn is less expensive. And then we have the opposite, the polyester nylon. Our Access Pro is actually a polyester sheath with a nylon core, which gives a nice handling ability and some give to the rope and a little bit of forgiveness should you do an uh-oh and slip a little bit. You're not falling on a cable in effect, and you can absorb some energy if something goes wrong. And then we have a bunch of different escape ropes of all nylon, all Technora, all Kevlar, and mixes of blends. Those are all our choices out there. And then we make water rescue ropes and polypropylene, Dyneema, and all nylon, and nylon with polypropylene cores, and all polypropylene, which are the really cheap ones. So all different choices depending on, once again, what's most important to you, whether you want a lot of wear or whether you want it to float no matter what, or something in between. And in conclusion, I tell people this all the time: no one rope. Construction is the one that's going to do everything. Nobody's ever been able to make one rope that does everything, so you're probably going to want several of these out there, bags in your bags of trip, different ropes for different things. And you really need to make sure that whoever's buying the rope knows how you're going to use it, and gets applied for the appropriate intended job, the appropriate rope for the intended job. Those are really important issues to make sure. That's what this whole talk is about, is to try to give you guys some ideas to why you might choose one over the other, and I hope that's helped you some.